All right, so here we have theorem 2, and basically it says assign properties on an interval, open interval a to b. And so if f is continuous on the open interval a to b, and f of x is not equal to 0 for all x in that interval, then either f of x is greater than 0 for all x in a, b, or f of x is going to be less than 0 for all x in a to b. So it's either going to be all positives or all negatives. It's not going to switch there. So hence f of x cannot change signs on the open interval a to b. And so it's either going to be always positive or it's going to be always negative. It's not going to switch signs. And because of that theorem, then what we can do is we can use it and we can make a signed chart or graph, and we can find out what intervals it's actually going to work on. So because we want it to be less than 0. So when we get done, only things that make on the left here, this true statement are going to be on the interval that works. All right. So first things, what do we have here? Well, because of this, we know there's a 0 at x is equal to 3. And if we have this, set this numerator and solve for that, x is going to be equal to plus or minus 1. So plus or minus 1 will make this to be 0. Okay. And so now what we need to do is we need to start making this sign chart here. All right, so what we need to do is we have at a plus 1 and a minus 1. So let's say we have a minus 1 here. Let's say we have a plus 1 here. Okay, so those are going to be zeros. And that's because the numerator, if you set that equal to 0, that'll tell us where our zeros are for the numerator. Okay. Now, what else do we know? At 3, it's not going to work. So we know out here at 3, let's call that 3, it's not going to work because if we have a 3 here, then there's going to be kind of this disconnect. So that won't work. All right, so what else do we know? That's about all we know. So now what we need to do is we need to find some test points. And what we'll do is we'll go in between all these places and find test points. So let's go over here to the left and let's do a -2. And this is going to be a test because we want to see if this region is going to be fulfilling this less than 0 or not. And then let's do something between 0 and 1. Well, how about I mean, a -1 and 1, so let's do 0, and that's going to be a test point. Let's go between 1 and 3, so I don't know, how about 2? And let's go one beyond that, let's do 4. Okay, so these are values basically. Where's our test and test? So these are the values we're going to plug in on the left side, and then we're going to determine if it makes a true statement here or not. If it's a true statement, then we can say, okay, well, those are negative. If not, well, then we'll say they're positive. So -2. -2 squared is 4, minus 1 is 3. And then here we have a -2 minus 3. That's going to be -5. And so that's going to be a -3/5. Well, that's less than 0, so that's true. So it's negative. So that region is negative. So this is a good region for us. What about if we plug a 0 in? Well, 0 and 0, that's going to be a -1 over -3. That's positive. That region we don't like. It's kind of we don't want that region because it's positive. What about if we plug in a 2? Well, here it's going to be 4 minus 1. It's going to be a 3 again. And here's 2 minus 3, so it's going to be a -1. So that's going to be a -3. Well, so that means that region is going to be negative. So this is good. This is good. That's bad. Now, what about a 4? 4 squared is 16 minus 1, so that's 15. And 4 minus 3 is 1, so that's a positive 15. And so that region out there is going to be positive. We don't want positive, so that doesn't work. So it looks like the regions that's going to work here are going to be between -infinity and this point here are 0, -1, union. And now we go to the next piece, so it's going to be going from 1 all the way up to 3. Okay. And again, we're not including those endpoints because those are zeros, and that one was it was a makes the 0 on the denominator, so it's going to be a vertical asymptote, so it won't work there. So that would be then our solution that it wants there. So what x's work, those x's work, and we can do that because The signs aren't going to change in the interval. So if we find one point here and it says it's negative, no matter what other point I choose out here, it will be negative as well. Same here. I could have done, you know, 0.5 or a negative 0.5 or whatever, and all those are in here are going to be positive. So I only have to choose one to test, and that will give me the region. And same here, and same here. All right, so let's stop there, and then we'll come back with some more definitions.